Okay, class, in this lesson, we are going to learn to use properties of logarithms to rewrite expressions. Okay, so let's go ahead and get started. First, we're going to need to review the properties of logarithm. Okay, and if we take a look at these first three, the first one is the product property of logarithm. Okay, product property of logarithm. And this basically states that the log of mn base b is equivalent to the log of m base b plus the log of n base b. Okay, so if you take a look, what essentially is happening is these products here are being broken out into two separate parts, okay, m and n, with an addition in between. Okay, similarly, if you take a look at the second one, the quotient property of logarithms, we see that the log of m over n base b is equivalent to the log of m base b, so this is the numerator part, minus the log of n base b. Okay, so when we have a quotient, or a fraction in this case, m over n, it is the same as the log of each of those with the same base with a subtraction in between. Okay. The third property here is the power property of logarithm, and that is as follows. The log of m to the n power base b is the same as n log of m base b. Okay, so all that's happening here is that this power goes to the front, okay, and here it is, Rn. Okay, and then the last one, this is a useful one. We're not going to go through examples of this, but this is a useful one when you're dealing with logs of different bases, okay? So when you have a log of m with a base b, that is equivalent to log of m base a over log of b base a, okay? So again, when you have, let's say, log of base 2, let me just go ahead and write this down. Log of base 2 of 4, okay, plus log of base 3 of 9, that is really the same thing as, I mean, you could break this up so that this becomes log of 4 over log of 2 plus log of 9 over log of 3, okay? And what this essentially does is it puts everything in a base 10 log, okay? You could choose to use any other bases, but 10 is the most popular one. But this property, change of base of logarithms, allows us to keep all of their bases the same. So we go from different bases to all the same bases. Okay, now let's go through a few examples on how we might break the following example up, okay? So what we're going to do is use properties of logarithms that we just covered to expand each expression, okay? The expanded logarithm expressions should have arguments with no exponents, no products, or quotients, okay? So let's start with this first one, log of 2x base 5, okay? Log of 2x base 5 is essentially the same as log of 2 base 5 plus log of x base 2, okay? If you notice, we just took this product and broke it up into two separate parts, okay? Now let's go to the next example. Log of g over h base 7. That is going to equal log of g base 7 divided by log of h base 7. Okay, so essentially what we've done, I'm sorry, I did that wrong. Log of g base 7 minus log of h base 7. Okay, there we go. Sorry. So if you notice, what we did was we took this fraction and broke it up with a subtraction by making a log of each of the components, so g and also of h. Okay, now let's take a look at the next example. We have the log of the square root of x. Okay, first we want to rewrite this log in terms of an exponent. So this is going to be log of x to the 1/2 power, okay? And to rewrite this, we're going to take this power and move it up to the front. So this becomes 1/2 log of x. All right, next example. We have the log of 8a squared b to the 5th base 2. Okay, so first we're going to separate these out into different products. So this becomes log of 8 base 2 plus log of a squared base 2 plus log of b to the 5th base 2. Okay, see how we have the product of 8 times a squared times b to the 5th. So we broke these up into log of each of those. 8 a squared b to the 5th. Now we need to resolve these exponents. And as we know, according to the property, these exponents come to the front of the log. Okay, so then what we end up getting is log of 8 base 2, nothing changes there, plus 2 times the log of a base 2, plus 5 times the log of b base 2. All right, another example. We've got log of 16w cubed over x squared, x to the 6th power base 4. Okay, so first we're going to separate these. This becomes log of 16w cubed base 4 minus log of x to the 6th base 4. Okay, we have this fraction here, so we're going to break it up into separate logs with a subtraction sign. Now we're going to need to resolve this exponent as well as this one. Again, these come to the front. Okay, this also comes to the front. So then this becomes 3 log of 16w base 4 let me redo that. Before we bring the exponent down, we actually need to break this up again. I didn't notice this immediately, but if you notice, there's actually a product, 16 times w cubed, okay? So we need to break that up further. So this becomes log of 16 base 4 plus log of w cubed base 4 minus log of x to the 6th base 4. Okay, now we can bring these exponents down. Okay, this exponent comes in the front as well as this. So now this becomes log of 16 base 4 plus 3 log of w base 4 minus 6 log of x base 4. All right, and then the last one, we have a natural log of a plus 1 over the cube root of b minus 2c. Okay, when we're dealing with natural logs, the properties of logarithms still apply. Okay, so let's go ahead and break this up. This becomes the natural log of a plus 1 minus natural log of the cube root of b minus 2c. All right, and then this breaks out to natural log of a plus 1. Nothing changes there, but we're going to go ahead and rewrite this natural log as b minus 2c to the 1/3 power. Okay, now what we can do is move this power up to the front, and so this becomes natural log of a plus 1 minus 1/3 natural log of b minus 2c. Okay, so now the next set of examples, what we're going to do is use the properties of logarithms to now condense each expression. So now we're going to go backwards, okay? The condensed logarithm expression should be written as a single logarithm with no coefficient, okay? So here we've got these broken out. We want to bring these together, okay? So the first thing we want to do is move this coefficient to the power, okay? We're going to move this back up. So then this becomes log of 4 cubed minus log of k squared. Okay, now that we have the subtraction, we know that this is going to become a quotient, okay, or involving a fraction. So this is going to be log of 4 cubed over k squared. Okay, let's move on to the next example. Okay, we have negative 5 log of x plus 1 base 2 plus 3 times the log of 6x base 2. Okay, first thing we want to do is move this coefficient up here to become a power. Same thing with this. Coefficient becomes a power. So this becomes log of x plus 1 to the negative 5th power base 2 plus log of 6x cubed base 2. Okay, now we have this addition, which means that both of these are going to be multiplied together. Okay, so then this becomes log of x plus 1 to the negative 5th power times 6x cubed base 2. Okay, and if you want to go a little further to eliminate or avoid this negative exponent, this could actually be written as log base 2 of 6x quantity cubed over x plus 1 to the 5th power. Okay, let's move on to another example. Okay, here we've got a few things that are involved. We've got 1/3 log of 10 base 4 plus 1/3 log of h base 4 minus 6 log of g base 4. Okay, so we're going to take all of these coefficients, make them a power. Same thing here, make them a power. And this one also here, make that a power. All right, so this becomes log of 10 base 4 raised to the 1/3 power plus log of h to the 1/3 power base 4 minus log of g to the 6th power base 4. Okay, so we're going to rewrite the exponential power into a radical. So this becomes log of the cube root of 10 base 4 plus log of the cube root of h base 4 minus log of the 6th root, we're going to keep that as is, log of g to the 6th power base 4. Okay, now we have this plus situation, so they're going to be multiplied together and then a subtraction, which will give us a division. So now we're going to have the log of base 4 of this entire thing. So this is going to be the cube root of 10 times the cube root of h divided by g to the 6th power. Okay, moving on to the next example. We now have a natural log of 3m plus 5 minus 4 natural log of m minus the natural log of m minus 1. Okay, so first what we're going to do is move this coefficient up here to become a power. So this becomes natural log of 3m plus 5 minus natural log of m to the 4th minus the natural log of m minus 1. All right, so now we have a subtraction scenario, okay, and another subtraction scenario. So this is going to become the natural log of 3m plus 5 divided by m to the 4th times m minus 1. Okay, and I believe that is it for that particular problem. And then now we have one more example. We have log of 20 plus 2 log of 1/2 minus log of x plus 3 log of y. Okay, so we got a number of components here. So let's go ahead and resolve these coefficients first. So this becomes log of 20, nothing changes there, plus the log of 1/2 squared, okay, minus the log of x, nothing changes there, plus log of y cubed. Okay, so this becomes log of the following. So we've got 20 times 1/2 squared is 1/4. Okay, and we have the subtraction. So I'm doing a couple things here at all in one time, so I want to make sure that you're clear on what's going on here. We have an addition here, right? So this becomes a product. We now have a subtraction, so that's going to be a division here. So that's going to be divided by x. And then we have a positive here, so that's going to be a multiplication. So this becomes times y cubed. Okay, and then further simplifying this becomes log of 5y cubed over x. Okay, so hopefully this made sense to you. We were using all three of the logarithmic properties in these examples. First, breaking them apart and then putting them back together. If any of this was confusing or if you need further clarification, please go back to the beginning of the video and listen to it again. Thank you.